The National Electrical Code, or NEC, mandates that underground service entrance conductors, which run from the utility transformer to the building's service equipment, must include a ground wire. This ground wire serves a critical purpose. It provides a pathway for fault current to return to its source, ensuring the electrical system is properly grounded. This grounding is essential for safety and proper operation. Now let's discuss separately derived systems. A separately derived system is an electrical system that operates independently of the building's main electrical system. It has its own power source, such as a generator or a solar array. These systems require their own grounding arrangements. A key aspect of separately derived systems is that they must have their own ground electrode system, distinct from the main system's grounding. This independent grounding is crucial for safety and proper operation. While it might seem convenient to utilize the ground wire included with the underground service entrance conductors for grounding a separately derived system, this practice is strongly discouraged and can create significant safety hazards. The NEC stipulates that separately derived systems must be grounded independently of the main system. Sharing a ground wire between the main system and a separately derived system can lead to problems. The current from the separately derived system could flow through the main system's ground wire. This could overload the ground wire, increasing the risk of fire or electrical shock. It's crucial to understand the potential dangers of improper grounding. Consider a scenario where a fault occurs in the separately derived system. If the ground wire is shared with the main system, the fault current could travel through the main system's grounding path. This can create a dangerous voltage potential on grounded metal parts, posing a shock hazard to anyone who comes into contact with them. Furthermore, overloading the ground wire can cause it to overheat, potentially leading to a fire. Therefore, it is important to adhere to the NEC guidelines and ensure that separately derived systems have their own dedicated grounding electrode system. This system typically consists of a ground rod or other approved grounding electrode driven into the earth. The grounding electrode is then connected to the separately derived system's equipment grounding conductor and neutral conductor, if applicable. This creates a low impedance path for fault current to flow back to the source, tripping the overcurrent protection device and de-energizing the circuit. In summary, while a ground wire is required for underground service entrance conductors, it should not be used as a ground for a separately derived system. Separately derived systems must have their own dedicated ground electrode system to ensure proper grounding and safety. Proper grounding is essential for protecting people and property from electrical hazards. It's crucial to consult the NEC and follow its guidelines when installing and grounding electrical systems. This includes ensuring that all grounding connections are properly made and that the grounding system is adequately sized to handle potential fault currents. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to minimize the risk of electrical shock and fire. It's important to understand and comply with these requirements to ensure the safety of electrical installations. When working with electrical systems, it's always best to consult with a qualified electrician. An electrician can assess the specific requirements of your installation and ensure that it is properly grounded and protected. They can also help you to identify and address any potential safety hazards. Grounding is a critical aspect of electrical safety. By following the NEC guidelines and working with qualified professionals, you can help to ensure that electrical systems are safe and reliable. Remember, electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. Always de-energize circuits before working on them and use appropriate safety equipment. Also, perform regular inspections of electrical systems to identify and address any potential problems. Here are some additional points to consider regarding grounding and separately derived systems. Firstly, the size of the grounding electrode conductor for a separately derived system is determined by NEC Table 250.66. Secondly, the grounding electrode conductor must be connected to the system's neutral point, if any, and to the equipment grounding conductor. Thirdly, the grounding electrode system for a separately derived system must be located as near as practicable to the system's power source. Fourthly, the grounding electrode system must be independent of any other grounding electrode system. Fifthly, the bonding jumper between the separately derived system's neutral point and the equipment grounding conductor must be sized in accordance with NEC Table 250.102. Sixthly, the equipment grounding conductor must be sized in accordance with NEC Table 250.122. Seventhly, all metal enclosures containing electrical conductors must be bonded together to form a continuous electrical path to ground. Eighthly, any metallic water piping system that is used as a grounding electrode must be supplemented by an additional grounding electrode. Ninthly, any concrete encased electrode that is used as a grounding electrode must be at least 20 feet long. Tenthly, any ground ring that is used as a grounding electrode must be at least 20 feet in circumference. Following these guidelines will ensure that the separately derived system is properly grounded and that the risk of electrical shock and fire is minimized. Remember that it is very important to verify the local requirements and have a qualified electrician perform the work so that it is performed safely and in accordance with the regulations. In summary, the ground wire in underground service entrance conductors is not a substitute for a dedicated grounding system for separately derived systems. Adhering to the NEC guidelines is paramount for ensuring electrical safety and preventing potential hazards. Consult with a qualified electrician for proper installation and grounding of electrical systems. They can assess your specific needs, ensuring compliance with the NEC and local regulations, as well as protecting people and property from electrical dangers.